Welcome back to the True First Person Tutorial series. In this episode we will create a procedural walk-in animation. So let's get started. First we want to fix one bug, and that is our join target fix. So you can see when we look up, our join target is always at the same position, so you can see it's a bit moving, and it's moving a bit too much, and let's just change it. It's pretty easy, and you can modify it anytime. Let's go into our engine blueprint, and here let's click on the skeleton, and here's our mannequin skeleton. And let's create two more sockets. So let's click on spine 3, then add socket, and let's call this the hand R joint target location. Then let's copy this, click on spine 3 again and paste it, and then let's call it hand L. Okay, so now let's position it. So hand R, let's move it to the right arm, maybe like this, yeah, and on the left side, like so. Now in our TFP and in blueprint, let's go to the update graph. Then out of our character reference, let's get the mesh. Here we get the socket transform, and then let's copy the name from our socket. Let's duplicate this here, and let's change it to R. And now let's split the return value here, like so. Then let's get the left hand join target location. Plug that in, and the right hand, like so. Okay, and now when we hit play, now you can see they're not in the right position yet. So let's do some little split screen here. So let's do a little split screen here. So here's our game, and we can see that our right hand is bit okay. So right now you can see that the join target is not affected anything. Yeah. Oh, okay. We have to change our transform space to RTS component, and that should fix it. Yeah, now you can see it's a bit too much, but on the other hand, on the right hand, it's also a bit too much, I think. So let's hit play, like so. Then let's grab our skeleton here, and then let's modify it a bit. So let's grab hand R, no, hand L, and then let's modify it, and also hand R a bit more, like so. And now we can see when we look down and look up, you can see it's always at the same position. So not always at the correct right position, but that is what we want. So it's looking more realistic. And here you can see the hand is more moving than the complete arm. So that is also a big realistic point here. And also for the right hand, let's modify it a bit more, like so. Yeah, that should be better, I think. Yeah. Let's save. Yeah, like that. So now you can see when we are walking, you can see nothing is moving except our head a little bit. You can see it's moving up and down, but we want to add a procedural walk-in animation for the weapon here. So let's get started. First, let's add a comment for this and call it variables, like so. And then let's get started. So let's close our engine blueprint first, and then let's go to the character blueprint, so TFP character BP here. Here's our weapon sway function. Let's close this. Then let's add a new graph. So add a graph. Let's call this the procedural graph. In here we will create the procedural walk, the procedural recoil, procedural aiming, and any procedural animation you want, procedural sprint, I don't know. So let's get started. Before we start, I just want to say this walk-in function is also from octahedron. It's a very, very nice function, and it's very nice, I think. But I modified it again, so it's perfect for a true first person, because octahedron only created it for first person with only the arms, and not for true first person with just one mesh. That is a bit more complicated, so I took a bit time and I changed it so it's working for a true first person. So let's get started. We start with a timeline. So let's hit right click, add timeline. Here, let's call this the walking underscore TL. Like so. And now let's create some new values in here. So let's open this up. First, let's set the length to 1, and let's add a flow track here. The first one will be the left and right track. Left and right alpha. So we just add 3 values here. 1 key, at the end a key, and in the middle a key. The first one will be 0 and 0. The second one will be 0.5, 0.5 and 1. And the last one, obviously, 1 and 0. Like so. Let's add a bit of interpolation here. Alright. Now we're done with the first one. Let's add a new track, a new flow track. The up and down alpha. This one will be a bit different. So, again, 2 keys at the beginning and at the end. 0, 0, 1, and 0. Then one will be at 0.25. Another one will be at 0.25 and 1. Then in the middle there will be a 0.5, so 0.5 time, and 0.4 value. And then, again, 0.75 and 1. And let's interpolate this also. And that is our up and down. Oh, I misspelled it here. Up and down alpha. Then let's add a roll alpha. So add a float, roll alpha. And here the first key won't be at value 0, it will be at time 2, at time 0, and value 0.18. Then the next key will be at 0.15 at time and value 0. The next key will be at 0.4 and 0.5 value. The next key will be at 0.7 and 1. And the last one obviously at time 1, and like our first key at 0.18. So now let's interpolate this again, like so. Let's rotate this a bit here, like so. And also here a little bit, I think. Okay. And now let's add our last track here, a flow track called forward and backward alpha. And this is just like our left and right. 1 key at 0, 0, 1, 0.5, 1, and 0, 0 again. Oops. 0, 1 and 0, and 1 and 0. And now auto interpolate here and compile and save. Before we close this, let's enable useless keyframe, autoplay, and loop. And so this will automatically play. So let's add a branch here if we're actually sprinting. So let's add a branch, and let's get the gate. And when this is not equal enum here to sprinting. Then we'll go on with the code. So we will add a sprint animation for every weapon, or we will also create a procedural sprinting. I'm not sure right now, but yeah. Alright, let's get started with 3 lerps. So let's start with the left and right. Lerp, this will be the alpha. The values will be -1 and 1. Then let's go on with the up and down. Set another lerp and the alpha. The value will be -0.3 and 0.3. And then another lerp for forward and backward. Lerp to the alpha. And this will be 0 and 1. So now we have our 3 lerps here. For the roll, we will add something, a new lerp later. But let's get started with a new variable. So let's create a new variable here. Let's call this the walk and position. This will be a vector. So let's set it after the true. Let's split the value here. Alright. So our forward and backward will be the X position. Then our left and right will be the Y, and our up and down will be the Z. Alright, that is our first variable. Nice. Alright, now let's go on with our second variable. So let's create a new one. Let's call this the walk anim rotation. And this will be a rotator, obviously. Like so. Then let's set it here. And here we will also split the struct pin. And let's get the roll alpha here. So let's add some space here. Let's move it here and add a lerp into the alpha. And let's add some reroute nodes here between them. So everything is nice and organized. Like so. Then our variable, our value will be -4 and 4. And now let's add a bit of interpolation here. So let's add a interp2. This will be the target. Then let's get the walk anim rotation. Let's split the struct pin. And we get the Y value here. Then let's get the world delta seconds. For the interp speed, we get the world delta seconds again. Then we'll divide it by, so we will divide 1 by it. And then we will divide our interpolation value here. So we will divide 1 by the world delta seconds, and then we will divide this value here by our interpolation speed. So let's say 4. Put this into interp speed here. Alright. And this will be our Y rotation value, so the pitch. Okay. So now let's set the intensity of the play rate. So first let's create a new variable, and let's call this the walk anim alpha. And this is a float. Alright, let's add some code here. So let's get the velocity and vector length. So it's a float. Then let's multiply this by 0.86. Then let's add a normalized to range. And the minimum is 0 and the max is 165. Now let's add a select float after this. The boolean will be get the character movement. Let's just get it here. Then let's get the movement mode. And when the movement mode is equal, it's equal to falling, then yeah, we'll pick A, so we're not moving, so it's not playing the walking animation. And on B, then we're not falling, then we're on the ground and walking. So right now it should work, so when we move, then it will set the walk anim alpha to a higher value, then we will walk, and based on your speed you will play the animation faster or slower. So first let's set this up. So this is our alpha, so let's get the lerp again. This is our alpha, obviously, and A is 0, B is 0.8. And now let's set our play rate. So let's get under components, let's get the walking TL, and then let's set the play rate here. This is our new play rate. Okay. So, oh, here's something, I don't know. Okay. So this is our walking function. So let's create a comment for this, and let's say walking, procedural walking, like so. And then let's also add a bit of color here. So let's make it more black. And then let's add a comment for every of these variables here. So walking rotation, walking position, and here walking speed. So let's add some more space here. Everything is nice and clean, and it's nice to understand if you want to modify the code here or change some values, so that is no problem then later. Okay, so we don't need to call anything here because it's automatically playing our timeline here. So before we implement this into our NM blueprint, first let's clean our variables up a little bit here. So let's create some groups. Okay, so let's start with our new created walking animation. So let's start with walk and pause category, and this will be procedural first. Procedural. And then we need to add this slash here, I don't know, this straight slash. And then let's say walk and anim, like so. So we have two categories here. And then let's also move the anim walk anim rod here, the walk anim alpha. Then let's start with camera offset. Let's also say procedural, then this slash again, and then say weapon sway, and offset, camera rate, camera current, pitch, offset, pause, and spine rotation pitch. And now our variables are cleaned up. Let's compile and save. And now let's implement this into our animation blueprint. Okay, so let's open up our anim blueprint, and then let's get our two new variables. So let's get the walk anim position, promote a variable, like so. And then let's get the walk anim rotation. Alright. Now let's go to the anim graph, and then let's add some space here. And what we're gonna do is we copy our weapon swipe function here. Let's just copy all the nodes. So let's add a comment first, and let's call this the procedural walk-in animation. And now let's change the variables here. So change this to walk and run. And here for the hand R, offset to walk and then pause. Make sure your joint targets are here again. And now that should work. And now you can see we have a very nice looking walking animation. And you can see it's working fine. And when we're sprinting, it stops. And when we're walking slow, you can see it's also playing slower. So you can modify all your values here and all your timeline values. And if you want to change this, yeah, it's a procedural animation. You can change anything here. You can change all your values and all your animation things, all your things on the timeline. It's maybe a bit too much, so let's change this later. Yeah, so you can see when I press Control, then we're walking again, and then you can see it's playing slower. So let's just change the rotation a little bit. So let's set it to 2 and -2. Maybe. And yeah, I think that is a bit better. So much rotation. Yeah, I think I like that. So that is a good walking animation. Okay, I like that. So big thanks to Octahedron for this code, and yeah, I modified it obviously, but it's still his code. And you can see when we're jumping, it stops playing. So then we can add procedural jump animations, procedural dip animations, so when we're landing. And also you can see with our spine fix, you can see when we're crouching, our arm is always at the same position and in the right position. Thanks for watching. In the next episode we will create a line trace for our weapon and we will prevent the weapon clipping. And again, it would greatly support the series if you would become a channel member, so thanks to Kieran, Battle Scars and Punigard. Every channel member gets the project files from every new tutorial.